Assalamualaikum and hi everyone to all panels. My name is Lucianti Mazlan. I am representing my group, team members of Vehicle Intelligence and Telematics Lab, UITM Shah Alam. We are applying for Anchor IV Asian NCAP grant proposal title in Vehicle Child Presence Detection, iV-CPD. So our group is collaborating with the industrial collaborator from Amtel Cellulose near Berhad. So this is our team members led by Associate Professor IR Dr. Fadlan Hafiz Helmi Kamaruzaman. So a little bit introduction about the topic that we are proposing. This topic is being proposed because of the frequent death cases of unattended child in the car, especially during a hot season. So this particular event in the car, in the carriage that is being left, the temperature at a time could reach up until 65 degrees Celsius, and if there is any presence of unattended child, this could be could contribute to a very dangerous situation. And we know that it takes only less than half an hour for an unattended child in the car to encounter any fatal danger that could also lead to death. All right, so this in particular is very crucial. Okay, it is required very crucial element in the vehicle safety ecosystem to provide a child presence detection system that is seen to be a potential solution to prevent this kind of tragedies. And current technologies commonly are using cameras or PIR sensors is widely used. But however, although they can actually detect the in-vehicle presence and the activities of the occupant, but however, these solutions have few limitations, okay, such as for camera base, okay, it has been seen to be taking a lot of computational costs in terms of memories to process the images, okay, and it's also sensitive to a certain condition like ambient light, and also there are privacy issues concerning the images that has been taken. And for the PIR and also, for example, ultrasonic sensor-based solutions, although they are able to detect the occupancy, but they are insensitive to a low-level motions and require a direct line of sight, in which sometimes when the occupant is being occluded by something, like for example when the child is actually sleeping and covered by a blanket, so this kind of technology base couldn't actually provide a solution, okay. So therefore, in this project, we are proposing a technology in detecting the unoccupied in-vehicle child presence using a radar operating frequency modulated sensors. Okay, and we are also integrating micro Doppler features. All right. We are proposing this because of the capability of the functions to alleviate the previous concern, the privacy concern, detecting micro motions like human vital signs, and also this kind of technology offers a through the wall detection capabilities that can solve the occlusion issues. So this is also in line with the requirement of ASEAN NCAP Roadmap 2021 to 2025, and it is hoped that this project could provide a feasible solution that suits the child occupant protection pillar, and also to improve the car safety standard. So what we are proposing here is a technology that is contactless and it's non-intrusive system that is able to detect the unattended in-vehicle child, and it also provide a compact high-performance solution which is suitable for vehicle integration, as well as its ability to distinguish between the different class of age group of the unattended child. So the objectives are to develop an unattended child detection system based on radar sensor and imaging to implement the system in identifying occupancy and classifying different types of unattended child, to evaluate the performance of the proposed systems and verify based on ASEAN NCAP assessment protocol rating. So this the overall framework, which can be seen to be divided into two main parts. The first one is the radar sensor and the second one is the radar imaging. So basically we are proposing to use the 60 gigahertz millimeter wave radar sensor with fast chirp modulation. So this is in particular very useful in detecting a very sensitive radar information. So we are proposing it to be attached, the hardware will be attached to the overhead console with a certain tilted angle that is based on the different types of vehicle and also cabin dimension. So that is based on the different types of vehicle. So in hope that the position of the radar sensor could approximately illuminating the entire vehicle interior. So this radar sensor will have 2 transmitting and 4 receiving antennas to achieve 2-dimensional data. And with the capabilities of micro Doppler spectrum, which can be used to distinguish between the different signal of moving and stationary objects. And based on this micro Doppler spectrum as well, it will basically provide us data where we can actually integrate and try to come out with what we call as 3D radar imaging. So this 3D radar imaging will be processed using a certain OGM methods. OGM is occupancy grid mapping. We have a lot of methods here. So it is actually help us to map the data that we got from the micro Doppler spectrum into 3D. So why the 3D data is important here is because based on the mapping and the visualization of 3D, it is hoped that we can be able to distinguish the position, the seating position of the occupant, whether it is forward or rearward facing, and whether it is adult or children. And the most importantly to our project is to classify whether the child, the presence of child is actually correspond to different class of subject, infant or toddler. So this is basically the flow chart of our system. It will start off with activating the onboard electronic systems and then looking into whether the vehicle is stalled or not, checking the driver occupancy. So if the driver is not occupant, then obviously we have to check the passenger, and if there is an existence of the passenger, so that could lead to the existence of unattended child. So we have the child presence detection module over here, which will detect the different and classify different types of child subject, whether it is class 1 infant with sitting position rearward facing, and also class 2 toddler with forward facing sitting position. So these will be taken into account parameters such as a different age group and also the use of different size of dummies. We are proposing to use the Q half and also Q3 for the detection or any appropriate size that could classify between the two age group. And then the alert system module will be activated, in which we have three different types of notification. The first one is 0 to 3 minutes, the second one before the 4th minute, and the third one is being activated before the 5th minute. And the alert system will activate a car horn warning, first one, and also sending out message or call via GSM or any mobile module to the driver. So the first one could possibly help give a prompt help, okay, because the car horn will actually give a warning not only to the driver but also to the nearby pedestrian. That is what more important for a prompt action. Okay, if there is an existence of unattended child, and the mobile GSM will alert, give notification to the driver if the driver is not nearby to the car. So once it is developed, we will undergo system testing, which basically will test the functionality of the hardware and software, okay, via a few testing methods. And also we will try to do testing so that it is in line with the assessment protocol for child occupant protection, based on the detection of the subject, CPD assessment phase, and also reminder system, because basically our module is being designed to be in line with the assessment protocol. This is the project milestones, consists of identifying system requirements and specification, design system and architecture, system development and integration, testing, and final reporting that will end by 30th of June 2023. So this is the estimated budget, mainly for our researchers' salary for 12 months, and the remaining for the requested hardware for this project. In total, we are requesting at about 42,000 for 1 year project. As the outcomes, so the proposed system can be used by ASEAN NCAP and also car manufacturers to enhance the safety of vehicles in addressing especially the child occupant protection pillar. In terms of research for the academicians, this could provide a basic framework for a start, okay, as a platform for future radar imaging research in classifying class of children for in-vehicle presence, and also to the extent of predicting the respiratory signal using machine learning methods. Okay, so that's all for my presentation today. So I hope that this proposal will be accepted, and I hope to be able to work more closely with the collaborator, industrial collaborator, and also ASEAN NCAP organization. Thank you. Assalamualaikum.